Welcome to Recording 1B in our series on solving quadratic equations by completing the square for Unit 4, Chapter 4 of Mathematics 2200. We'll be focusing on how we can use completing the square to solve quadratic equations. Kind of a good link to what we did back in Section 3.3, Chapter 3, when we went from standard form to vertex form of a quadratic function. And also from there, a little bit of review. A perfect square trinomial is a trinomial which has two identical factors. So for example, x squared plus 6x plus 9 has the factors x plus 3 and x plus 3, which can be written as x plus 3 squared. Also, when we expand a binomial by squaring it, x plus d times x plus d in this case, we get x squared plus 2dx plus d squared, which gave us a clue on how to create our own perfect square trinomials. And we expanded this one, for example. So we have x squared plus 2 times 5 times x plus 5 squared would be the expansion, because as indicated up here, the d value is 5. So we have x squared plus 10x plus 25. For more on that, you can see the recording for section 3.3. Now, to create our own perfect square trinomial, we took the second term here, for example, and had to figure out what the value of d was. So 2d equals 12, which means d equals 6. And it was d squared that had to go in this blank. So that would be 6 squared, which is 36, would go in the blank. And the factors would be x plus d squared would be, in this case, x plus our 6 squared. So that's stuff we did back in section 3.3. Now, we want to use that along with the square root property we developed in our last recording to solve quadratic equations. So let's take a look at this example. X squared minus 10x plus 16 equals 0. How do we find the roots of that by completing the square? Well, our first step here says divide by the a value. But because the a value is 1, that's not going to make any difference. So we don't need that for this example. However, for our second step, it says group the x squared and the bx terms and isolate the parentheses. So that means we're going to have to bring the negative 16 across the equal sign, or the 16 across the equal sign, and subtract it. Next, we complete the square. So we take the terms that are in here, make a blank, and remember we have to subtract off an equivalent amount. Now for completing the square, we realize that the negative 10 is our twice the value of d that we need, so our d value is only negative 5. But it's negative 5 squared that has to go up here, so that's 25. Negative 5 squared, that's our d squared. And we have to subtract off an amount equivalent to that, because we can't just add what we want into an equation. We have to balance it off. Once we have that, we move that negative 25 outside the brackets. There's nothing to distribute, so move it outside the brackets. We factor our perfect square trinomial, which in this case becomes our d value is negative 5, so the factors are x minus 5 squared minus 25 equals negative 16. I'll go to a new slide. And we're now in a position to apply our square root property as soon as we get that x minus 5 squared isolated. So I've got x minus 5 squared equals 9 here when I add 25 to the other side. So x minus 5 equals plus or minus the square root of 9 That's plus or minus 3. So we've got two cases, x equals 5 plus or minus 3. Case 1, x equals 5 plus 3, which is 8. And case 2, x equals 5 minus 3. Okay, I've fixed that up a little bit, but x equals 2. For this next one, we follow the same steps, but this time the a value is -2, so we're going to divide everything by -2 in this equation. So when I divide everything by -2, I will get x squared plus 4x minus 6 equals 0. And we have to group the x squared and bx terms in parentheses like we did in the last example. Just tidy things up a little bit. Next, we complete the square in the brackets, x squared plus 4x plus a blank, subtract a blank, and that minus 6 we're moving to the other side of the equal sign. So then we recognize that this is double the d value we need. So d, it turns out to be 2, and we square the d value, which happens to be 4 again, and then we subtract off of 4. So just before I factor that perfect square trinomial, I move that minus 4 outside the brackets. Now I can factor the perfect square trinomial and move that 4 across the equal sign. I have 4 plus 6 over there. And so I now have x plus 2 squared equals 10. X plus 2 equals plus or minus the square root of 10. I have my two cases. So x will equal either -2 plus root 10 or -2 minus root 10. So in summary, the major steps for solving a quadratic equation in the form ax squared plus bx plus c by completing the square are: divide the equation by the a value, group the x squared and bx terms, complete the square, factor, and solve.